Okay, students, start करते हैं. Good afternoon to all. I hope you all are well at home. And today we will start next unit, unit 2 of our syllabus. That is the asymmetric cryptography, or we can say public key cryptography. You can also say public key cryptography. Okay, this is our first topic of second unit. And the first topic is asymmetric cryptography. See, we have two types of keys. We have two types of key. Okay, one is symmetric key and second is asymmetric key. One is symmetric key and second is asymmetric key. In symmetric key, we use only one key at both ends. We use only one key at both ends. Sender and receiver use only one key for encrypting and decrypting the data. But in asymmetric key, the both ends use different key. Both ends use different key. In asymmetric key, both end has a pair of key. Both end has a pair of key. For example, if we have A and B, A is the sender and B is the receiver. A has private key and also has public key. In the same way, B person has private key and public key. Okay, so this means both the end has a pair of key. One is private key and second is public key. Okay, this is the first difference between symmetric key and asymmetric key. In symmetric key, we have only one key which is used by both the ends A and B for encryption and decryption. Okay, but in asymmetric key, both the end has a pair of key. Okay, A has a pair of key, that is private key and public key. B has a pair of key, that is private key and public key. Okay, so this is the first difference between symmetric and asymmetric key. Now today our topic is asymmetric key. The main difference I have told you, the one is the asymmetric key has pair of key. Okay, and in asymmetric key or public key, we have two types of key. One is private key, second is public key. Private key is private to that person, to that end. Nobody can access the private key. If a sender, this key is private to only A. Only A person can access the private key. Nobody can access the private key. Okay, only A person can access the private key. And public key, as the name told, public, so this means this key is publical to everyone. Anybody can access this key, public key. Okay, okay, now if we want to transfer data, between A and B, suppose if as we know, A has public key and private key, but B also has public key and private key. Private key and public key. Private key and public key. Okay, so if A use the private key of A for sending the data, then B can encrypt the data of using public key. Okay, so this means when someone wants to send an encrypted message, they can use a public key to encrypt the message before sending it. The receiver of the message can then decrypt message using their related private key. Okay, suppose if A wants to send a data to B, A use the public key of B, then B can decrypt that message by using its private key. Okay, suppose if A wants to send data to B, A can use the public key of B and B can decrypt that data by using its private key. Okay, and the vice versa. If B want to send the data, then if A use its private key to send data to B, then B can use the public key to encrypt that data. Again, I am repeating, suppose if A want to send data to B, A can use the public key of B for sending the data before encryption, and use the public key of B and encrypt data and send the data to the encrypted data to the B. Then B can decrypt data by using its private key. Okay, by using its private key. And on the other hand, if A send data using its private key of A to B, then B can decrypt the data which is sent by A to A by using the public key of A, Okay, in this way, asymmetric encryption is used for encryption and decryption. Suppose if A want to send data to B, A can use public key of B for sending the data for encryption, and on the other side, B can decrypt the cipher text by using its private key. Okay, now suppose if A send data to B by using A's private key for encryption, then B can decrypt the message by using A's public key for decryption. Okay, this is the rule for how to use the asymmetric key. Okay, for example, this is the sender which sends a message by using, this is the receiver. For example, sender sends a message to B by using R's public key. Sender can send data to the receiver, and for encryption, sender will use receiver's public key for encryption, and this encrypt the data, then transfer this data through the transmission media or network No. Suppose we have sender and receiver. Sender will send the message and encrypt this plain text message by using receiver's public key. Okay, the sender will use receiver's public key and encrypt the message in the form of E. This is the encrypted message, and this message is encrypted by sender by using the receiver's public key. Okay, now this message is decrypted on the receiver side. This encrypted message is decrypted on the receiver side by the receiver by using receiver's private key to decrypt the encrypted message, and the receiver will get the plain text. Okay, in this way, by using asymmetric key, we can transfer data from sender to receiver. Okay, this is about asymmetric key encryption, or you can say public key encryption. Okay, also called it's a public key encryption. It uses two keys, a pair of keys for encryption and decryption. वही जो मैंने बताया आपको, public key known to everyone, private key known only to that particular person. Okay, all these are the few points related to the asymmetric key. Easy है, बहुत easy है, ठीक है? The next topic is digital signature. Any guess? Anybody? What is digital signature and why we use digital signature? Yes. Anybody? Digital signature. What is digital signature? Anchal? Anjali, unmute yourself.
यस सर।
हाँ जी, what is digital signature?
सर मुझे डाउट है।
हाँ जी बोलो।
सर आपने पहले बोला अगर हमें डेटा सेंड करना है ए टू बी तो बी ए का पब्लिक की यूज करेगा डेटा डिक्रिप्ट करने के लिए।
हाँ हाँ।
तो सर ऐसे कोई भी अगर किसी का भी पब्लिक की यूज कर सकता है तो फिर तो डेटा मतलब
देखो अगर ए क्या करेगा उसमें भी बहुत सारे आगे केसेस आ जाते थे, वो हमने इतना वो नहीं किया है, वो नहीं
सर लेकिन ए अपना डेटा भेजने के लिए प्राइवेट की यूज करता है और बी ए का ही पब्लिक की यूज करता है उसको डिक्रिप्ट करने के लिए।
यस यस यस, ये बिल्कुल सही है। ए जो है अपनी पब्लिक प्राइवेट की यूज करके बी को डेटा सेंड कर सकता है, ठीक है, और बी जो है वो ए की पब्लिक की यूज करेगा। ये तो देखो ये क्या सिक्योरिटी है, ठीक है ना। तो अब
सर तो ऐसे सिक्योरिटी तो रही नहीं, कोई भी पब्लिक की किसी का भी एक्सेस कर सकता है फिर तो।
हाँ वही देखो इसमें क्या थे, 3-4 केसेस आते थे। जैसे आप बोल रहे हो कि ए ने पब्लिक की से अपनी प्राइवेट की से उसको क्या किया, इनक्रिप्ट किया, और एनीबॉडी कैन एक्सेस दैट डेटा बाय यूजिंग एज पब्लिक की। जिसको एज पब्लिक की पता होगी ना वो सारे के सारे उसको एक्सेस कर सकते हैं डेटा को, ठीक है ना। तो ये भी केस हम क्या करते हैं इसमें कंसीडर नहीं करते, ये भी केस क्या करते हैं हम कंसीडर नहीं करते हैं। द वैलिड केस, जो वैलिड केस है दैट इज वैलिड केस फ्रॉम ए टू बी इज ए विल एनक्रिप्ट द मैसेज बाय यूजिंग बीज पब्लिक की, ठीक है ना। ए क्या करेगा, बी की पब्लिक की यूज करके डेटा एनक्रिप्ट कर देगा। अब ये डेटा एनक्रिप्ट हो गया, नो आफ्टर दैट नोबडी कैन डिक्रिप्ट दैट डेटा, सिर्फ बी ही उसको इनक्रिप्ट डिक्रिप्ट कर सकता है बाय यूजिंग इट्स प्राइवेट की, बाय यूजिंग इट्स प्राइवेट की। दिस इज द वैलिड केस। बाकी जितने भी केस बनेंगे ना दीज आर नॉट द वैलिड केस। 3 केस और बनेंगे वो वैलिड नहीं होंगे।
ओके सर,
ओके, दिस इज द वैलिड केस। 4 केस बनते हैं ये जो मैंने अभी बताया है, ओनली वन इज वैलिड, ठीक है। B will send the data to B by using B's public key. No, after once a message is encrypted in ciphertext into ciphertext, only B can decrypt that message. by using its private key. This is the security.
Okay,
ठीक
sir.
है, ये सिक्योरिटी के बाकी जो 3 केस बनेंगे ना, these are invalid केस. क्लियर?
Yes, sir.
हाँ, यस कुणाल.
ये सर वो डिजिटल सिग्नेचर्स पूछा था ना अभी आप.
हाँ जी, हाँ जी. व्हाट इज डिजिटल सिग्नेचर?
सर वो जब सेंडर एक मैसेज सेंड करता है तो उसके साथ एक इलेक्ट्रॉनिक सिग्नेचर साथ में सेंड करता है, और एट रिसीवर एंड रिसीवर वेरीफाई करता है और सिग्नेचर को, कि उससे पता लगता है कि वही सेम एक स्पेसिफाइड और सेंडर है वो.
ओके, यस यस.
जिसने भेजा डेटा.
ओके, यस यस. नो लिसन, digital signature. What is digital signature? Suppose if you need, nowadays आजकल जैसे लॉकडाउन चल रहा है कि आपने हेड सर को, हमारे एचओडी सर को आपने मैसेज किया. इफ यू मैसेज टू एचओडी सर, सर आई नीड दिस डॉक्यूमेंट. ओके, आई नीड दिस डॉक्यूमेंट. नो विदाउट, अगर वो जो डॉक्यूमेंट है, इफ दैट डॉक्यूमेंट इज सेंट टू यू विदाउट द सिग्नेचर ऑफ हेड, तो आपको क्या है, आपको वो मतलब कि आपके मानने में नहीं आएगी कि ये डॉक्यूमेंट मुझे हेड ने सेंड किया है या किसी थर्ड बंदे ने सेंड किया है. ओके, नाउ सपोज इफ ए एंड बी वांट्स अ डॉक्यूमेंट फ्रॉम ए, तो ए, अब ये देखो ए ने सेंड भी कर दिया आपको, बट विदाउट साइन सेंड किया है, तो आपके मानने में नहीं आएगी कि वो जो डॉक्यूमेंट ए ने सेंड किया आपको वैलिड डॉक्यूमेंट, दैट इज द वैलिड डॉक्यूमेंट. बिकॉज व्हाट सिग्नेचर स्पेसिफाई, सिग्नेचर क्या स्पेसिफाई करता है? इट स्पेसिफाई द ऑथेंटिसिटी ऑफ दैट डॉक्यूमेंट. ओके, इफ द डॉक्यूमेंट इज साइंड बाय हेड, देन यू विल, आप बड़े आराम से उसको क्या एक्सेप्ट कर लोगे कि यस दिस इज द वैलिड डॉक्यूमेंट विच इज सेंड बाय द हेड टू मी, and this document is not sent by another person. Okay, now suppose if C can send the document, D can send the document, okay, but the sign, the signature will specify the valid authenticity of that document, कि ये बंदे भाई ये जो डॉक्यूमेंट आया है मुझे वो वैलिड पर्सन से आया, अथेंटिक डॉक्यूमेंट है. ठीक है ना? what सो मेरे कहने का मतलब क्या है? व्हाट आई मीन कि विदाउट सिग्नेचर आवर डॉक्यूमेंट, वी कैन नॉट कंसीडर आवर दैट डॉक्यूमेंट वैलिड. ओके, फॉर दैट हमें क्या चाहिए कि हमें साइंड डॉक्यूमेंट चाहिए. फॉर एग्जांपल, एट द एंड you receive a degree from university without any signature. You receive your degree without signature, without sign of VC. तो क्या आप मानोगे दिस इज द वैलिड डिग्री? जब कोई और बंदा उसको मानेगा कि दिस इज वैलिड डिग्री? नो. क्यों नहीं मानेगा? क्यों? बिकॉज देयर इज नो साइन ऑफ अ वैलिड पर्सन ऑन द डिग्री. ठीक है? इफ आई वांट अ वैलिड डिग्री, दैट डिग्री शुड बी साइंड बाय VC और any other authority. Okay, so this is the main aim of the digital signature, and this digital signature is very important in case of e-commerce, online transactions, etc. In cases में जो हमारी digital signature है, that is very important in case of e-commerce, online transactions, etc. Okay, in these cases digital signature is very important. Okay, what we do in digital signature, how we electrically sign our document and send to the other party. For that case, in that case we have a message that we want to send, and by using the digital sign generator algorithm which generates the signature of a valid person, and then combine these two documents. One is the main message, and second document is the signed message, then merge and send it to the receiver. and a receiver at that end, receiver will verify by the verification algorithm that the document the receiver received is a valid document or it is invalid document. Okay, so the concept clear हुआ सबको क्या है? What is digital signature? Okay, it is very important for e-commerce and online transactions. Second thing is it is based on asymmetric key encryption. It is based on asymmetric encryption. Okay, encryption in this encryption, we do encryption by using private key, and decryption we do decryption by using public key. Okay, and the most important point of digital signature is that digital signature is used for authenticity, authentication. Digital signature is used for authentication purpose. Second, non-repudiation. Non-repudiation. And third one is message integrity. Message integrity. So digital signature is used for authentication, means the message that we receive or sent from the authentic person. Okay, this is authentication. Non-repudiation. What is non-repudiation? We have already discussed what is the non-repudiation in chapter 1 in security services. Anybody? Non-repudiation? Yes, Gagandeep.
So non-repudiation means nobody can deny that that particular thing is not belong to you or
Yes.
that person.
Okay, okay. Anchal?
So it is basically a protection that no one can deny by any of the communication internet.
Yes. ठीक है. Okay, non-repetitions means if A send a message B, then A cannot deny. A cannot deny to B that A send any message to B. Okay, non-repetition means nobody can deny that he or she send a message to other person. Okay, this is a non-repetition. It also digital signature is important in non-repetition. And the last one is message integrity. Message integrity means if A send a message to B, in between while sending the message, if there is any change in the message by any third person, then the verification that we do at the other end is show invalid message. Okay, अगर इंटीग्रिटी का मतलब क्या है कि मैसेज में कोई छेड़छाड़ हुई है, जो मैसेज सेंड किया ए ने वो हमें बी को वो सेम मैसेज नहीं मिला है. एंड डिजिटल सिग्नेचर आल्सो इंश्योर दिस that the message integrity should maintain. Okay, so digital signature is very important for authentication, non-repudiation and message integrity. Okay, digital signature ensures authentication, non-repudiation and message integrity. Okay, now the diagram for it, digital signature. Now, here we have a message or document, okay, that we want to send from A to B. Now, this message goes to the digital signature generating algorithm with the private key of A. With the private key of A, message is sent to the digital signature generator algorithm with private key of A, and this will generate a signature document. This will generate signature document. And after that, this signature document and this message document merged with each other and send it to the receiver B. Now the receiver will verify this message and signature document. Okay. Now the receiver B will verify this message and signature document by using the digital signature verification algorithm. वो वेरीफाई करेगा कि ये जो मैसेज और साइन सिग्नेचर डॉक्यूमेंट आया दैट इज द वैलिड और नॉट वैलिड, इनवैलिड. ओके, तो बी क्या करता है, बाय यूजिंग द डिजिटल सिग्नेचर वेरिफिकेशन एल्गोरिथम decrypt the message and verify that it is the valid message, and the receiver B will decrypt this message by using public key of A. Public key of A. Public key of A. Okay. Now again, if A wants to send a document to the receiver B, the sender will send a message or document to the digital signature generator algorithm by with private key of A. With private key of A, and message goes to this algorithm, and this algorithm will generate the signature document, and this signature document merged with message and signature document. Now listen, one thing, the sender will send two documents. One is the signature document and second is the signature document. One is the message document and second is the signature document. Okay, the sender will send these two documents separately. Okay, now at the other end, the B will decrypt this message. This is basically what we also do encryption here. Okay, we also do encryption and generate a signature document, and on the other hand we decrypt this message by using public key of A, and also verify that the message or document which is sent by A is valid or not invalid. Okay, and this we do with the digital signature verification algorithm. We verify that this message and signature document, okay, that this is sent by a sender by a authentic person, authentic or not. Okay, so the description will, what the description will do, this decrypt the message, ciphertext, okay, and then digital signature verification algorithm verify this message, that this message or document is sent by the verified person, okay, by using the public key of A, and then we get the plain text message, or you can say we get the valid document. ठीक है, बाय बी. देखो A ने तो सेंड कर दिया, B ने अब क्या करना है, वेरीफाई करना है कि जो A ने सेंड किया है ना दैट इज वैलिड डॉक्यूमेंट और नॉट. ठीक है, उसने वेरीफाई करना है इसको, और वेरीफाई क्या ऐसे करता है, डिजिटल सिग्नेचर वेरिफिकेशन एल्गोरिथम के थ्रू वो वेरीफाई करता है. क्लियर? ठीक है जी. मैसेज ऑथेंटिकेशन मीन्स पता चल गया आपको? मैसेज ऑथेंटिकेशन मीन्स authentic person will send the hello. Hello? Hello? Okay. So the digital signature, the first task of digital signature is authentication. It provides the authentication. Means authentic person have sent the message. Okay. Second is the message integrity. Message integrity means this message is once this message is decrypted, encrypted here. This is the encrypted message, and again at the other end this message is decrypted. ओके बाय यूजिंग हैश फंक्शन हम इसमें यूज करते हैं हैश फंक्शंस वैल्यूज वगैरह कैलकुलेट होती है ठीक है उससे हम ये मैसेज कंपेयर करवाते हैं जिससे हमें पता चल जाता है कि ये दिस इज आवर करेक्ट मैसेज दिस इज आवर करेक्ट मैसेज ओके so these few are the points related with digital signature okay if you have any doubt you can ask me. Yes, students. You have 2 minutes for poll. Amit Yadav, unmute yourself. Hello, Amit Yadav. Unmute yourself. देखो अगर मैंने किसी का नाम बोला ना अगर किसी ने आगे से रिप्लाई नहीं किया तो वो एब्सेंट है मेरी तरफ से आई विल एब्सेंट यू दिस मीन्स यू आर नॉट प्रेजेंट अमित यादव अनमोल शर्मा
यस सर
हाँ जी अनमोल शर्मा क्लियर है सब
यस सर
पता चल गया
हाँ जी सर
ओके हैव यू डन पोल yes or no send message Okay, I'm going to end poll 1. सभी ने कर दिया होगा आई थिंक. ओके ठीक है आंसर. I will send you the answer key. Okay, the next topic is number theory. Number theory. Not in detail, I will discuss number theory. I will discuss only the introduction of number theory, and basically in number theory, I will discuss only two things. One is prime number, and second point I will discuss in number theory is GCD. GCD means greatest common divisor. Okay, I will discuss only two things in number theory. One is prime number, and these two things only are related with our topic. Okay, so हमें ज़्यादा डिटेल में करने की जरूरत नहीं है. I will just discuss two things. One is prime number, second is GCD. Okay, as you all know, what are prime numbers? What are prime numbers? जैसे आप सबको पता है कि what are prime numbers? Prime numbers are those numbers which have only two factors. Which have only two factors, one and themselves. Okay, prime numbers जो होते हैं कौन से नंबर होते हैं? Prime numbers are those numbers which have only two factors. Two and themselves. मीन्स ये जहाँ तो ये अपने आप से ही डिवाइड होते हैं जो नंबर्स होते हैं. ठीक है, दीज आर दी प्राइम नंबर्स. ओके, और हमारे पास प्राइम नंबर्स कौन कौन से हैं? जो है कौन कौन से हमारे पास प्राइम नंबर्स है? वन एंड देमसेल्फ. ठीक है, वी हैव टू फैक्टर्स, वन एंड देमसेल्फ. Okay, so the prime numbers are 1, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37 and so on. Okay, these are the prime numbers which are divisible by 1 and by itself. Okay, वो numbers जो 1 जहाँ अपने आप से ही divide होते हैं, these numbers are called prime numbers. Okay, ये तो आप लोगों को पता ही होगा, बहुत जर्नल है, हम सभी ये सारी चीजें पता ही है. ठीक है, नेक्स्ट इज GCD in number theory. GCD. What is GCD? It is the greatest common divisor. We have to find greatest common divisor. Okay, we have to find greatest common divisor. If I say GCD of 12 and 8, you have to find the GCD between two numbers 12 and 8. How you find it? How will you find the GCD between two numbers 12 and 8? Okay, so firstly we see the numbers which divides 12. वो वाले numbers लेंगे जो 12 को divide करते हैं. जैसे for example 1, 2 is divisible by 12 is divisible by 2, 12 is divisible by 3, 4, 6 and 12 itself. Okay, these are the numbers which divides 12. 12 is divided by these numbers. Okay, now next 8 के factors find out करो. Find the factors of 8 which divides the number 8, that is 1, 2, 4 and then 1, 2, 4 and 8 itself. Now you have to find the greatest common divisor between two numbers. जो हमारा greatest होगा ना, common greatest divisor होगा, दोनों में जो common है, that is our GCD for 12 and 4. So here we have 4 is the greatest divisor which divides 12 and 8. So GCD, greatest common divisor of 12 and 8 is 4. Okay. Now let's take another example. GCD of 25 and 20. Now find the factors of 25 which divides 25. One is 1, 5 and then 25 itself, and then 20. What are various numbers which divides 20? 1, 2 divides 10, 20 is divided by 2, and then 4, 5, 10 and 20 itself. Now find the greatest common divisor between two numbers. Between two numbers we have to find the greatest common divisor. देखो 1, 2 नहीं है, यहाँ पर नहीं है, 4 यहाँ पर नहीं है, 25 ये है, तो एक ही हमारा नंबर है, that is 5. That is the greatest common divisor. So this means GCD of 25 and 20 is 5. Greatest common divisor for 25 and 20 number is 5. Okay. Now suppose GCD of 5 and 12. Now find the GCD for number 5 and 12. Here for 5 the divisors are 1 and 5 only. Only two numbers. For 12 we have 1, 2, 3, 4 and then 6 and 12. Now what is the common? What is common between two numbers 5 and 12? We have only common 1. We have only common 1. So this means greatest common divisor for 5 and 12 is 1. Okay. Now note down a line which is important. The numbers which has GCD 1. The numbers which have GCD 1 are called co-prime numbers. Called co-prime numbers. Numbers which have GCD equal to 1, that these numbers are called co-prime numbers. जिन numbers की GCD 1 आ जाती है, these numbers are called co-prime numbers. और यही हमें चाहिए next two topics में. Okay, we need GCD of 1. Okay, so I hope ये clear हो गया होगा concept. वो prime numbers क्या होते हैं? You are very familiar with the prime numbers. What are prime numbers? Okay, and then what is GCD क्या होती है? जिसमें हम क्या करते हैं? We find the greatest common divisors which are common between two numbers, and if the numbers which have GCD 1, the numbers which have GCD 1 means greatest common divisor 1, these numbers are called co-prime numbers. उनको हम क्या बोलते हैं? Co-prime numbers. So this means 5 and 12 are co-prime numbers. 5 and 12 are co-prime numbers. Okay, so this is about number theory. Now the next topic is Euler's quotient function. Euler's quotient function. यूलर्स थ्योरम आपने पढ़ी होगी शायद. So the next topic is Euler's quotient function. Euler's quotient function. Okay, Euler's quotient function is represented by phi. Is represented by phi. Phi phi. Okay, और इसको हम बोलते हैं Euler's phi function भी बोलते हैं, and also called Euler's phi function. Okay, so write down about Euler's quotient function is, it is defined as number of positive integers. Number of positive integers less than n. Less than n. Those numbers which are positive integers and less than n, that are co-prime to n. Co-prime to n means those numbers which are positive integers and less than n, and these numbers are co-prime to n. For example, suppose if we have 5, if we have a number 5, n is equal to 5, so what is Euler's quotient function? Means number of positive integers less than n. N is 5 and less than 1, 2, 3 and 4. These are the numbers which are less than 5, and these numbers should be co-prime with n. These numbers should be co-prime with n. Okay, now co-prime means अगर हम 5 और 1 का GCD निकालते हैं, if we calculate the GCD for 5 and 1, it should be 1. If we calculate the GCD for 5 and 2, it should be 1. 5 with 3, it should be 1. 5 with 4, it should be 1. You can calculate. How to calculate GCD? I have told you. 5 and 1. 5 के factors क्या है? 1 and 5. 1 का factors 1 है, तो 1 is common. So 5 and 1 की GCD क्या है? 1. So it is 5 and 1 is the co-prime numbers. Then again you can find the GCD with 5 with 2. 5 comma 2. 5 के factor क्या है? 1 and 5. 2, 1 and 2. Again we have GCD of 1. So this means 1 5, 5 2, 5 3 and 5 4. These are co-prime numbers. These are co-prime numbers with 5. So you can say, and this is not the Euler's quotient function. Euler's quotient function is total number of numbers in the set. Total numbers in the set. Total numbers in the set is equal to 4. Is equal to 4. This means phi of f. This means phi of f has Euler quotient 4. Euler quotient function 4 value. So this means Euler quotient function की वैल्यू कितनी आ गई? 4 आ गई. ये नंबर्स नहीं होंगे, काउंट होगा. सेट में जो नंबर, जितने नंबर्स होंगे उनका काउंट. दैट इज द Euler quotient function. 4 is the Euler quotient function. Now suppose if you have 5 of 6 करो, अब बताओ मुझे कितने नंबर्स जो co-prime थे with 6. 6 means, ये डेफिनेशन देखो, नंबर ऑफ पॉजिटिव इंटीजर्स लेस देन n. लेस देन n, कितने नंबर्स बनेंगे? 1 2 3 4 एंड 5। इनमें से वो नंबर्स जो को प्राइम्स है विद 6, वो बताओ कौन कौन से नंबर्स हैं विच आर दी नंबर्स विच आर को प्राइम्स विद 6? 1 2 3 4 5, कौन कौन से नंबर्स हैं विच आर को प्राइम्स विद 6? हरी अप, मैसेज मी। You have to find the GCD 6 with 1, 6 with 2, 6 with 3, 6 with 4, 6 with 5. Okay. After that, you will get the common divisor. Kamlesh Kumar 1 and 5. ठीक है। अंजलि ओनली 5, नो 1 and 5 है अंजलि। अभिषेक कुमार 1 2 3 5, नो। अंशुल 1 and 5, बिल्कुल सही। आंचल मित्र 1 and 5। देखो बच्चे, देखो जीसीडी निकालनी हमने, जीसीडी बिटवीन 6 एंड फर्स्ट नंबर लो 1। ऑब्वियस है 1 है तो 1 कॉमन आएगा, इसकी जीसीडी 1 आ जाएगी। मींस 6 and 1 क्या है? को प्राइम नंबर है। आफ्टर दैट यू हैव टू कैलकुलेट 6, 2। 2 इज नॉट, 2 जो हमारा दैट इज नॉट को प्राइम नंबर। 3 भी नहीं है, 4 भी नहीं है, एंड 5। सो 5 of 6, 1 and 5. So here what is the Euler quotient function? That is 2. That is 2. ठीक है। So number of elements in the set is the quotient function. Number of elements in the set is the quotient function. Clear? Yes students, clear? Clear or you have any doubt? चलें आगे? ठीक है। नो देखो, these are small numbers 5 6, these are small numbers. If you want to calculate GCD or you find out a co-prime numbers, you can find easily. But if you have big numbers, then there is a problem. Then ये तो है नहीं कि हर बार हम क्या करेंगे, इस नंबर को पहले सपोज करो आपके पास 23 नंबर है। If you have 23, you will write 1 2 3 up to 23, not 23. First you find the GCD 23 with 1, 23 with 2, 23 with 3, 23 with 4, and so on up to 22. Okay, that is very lengthy process. That is very lengthy process and very time consuming process. For that purpose, if we have a prime number, for prime number, okay, listen carefully. If we have prime number, then for calculating quotient function is very easy. Okay, if n is equal to prime, if n is prime means any number जो prime हो, if n is equal to prime, then how we calculate quotient function? Quotient function of n is equal to n minus 1. Simple. We no need to calculate all the lengthy calculations. You just calculate by using this formula. But this formula is valid for only prime numbers. But this is only for prime number. Clear? For example, if you have n is equal to 5, हमने 5 का कैलकुलेट किया था, हमारे पास क्या आया था? 5 का क्वोशिएंट फंक्शन कितना आया था? 4. 5 of 5 is equal to 4 आया था। Here you can also see 5 into 1 is equal to 4. So quotient function of 5 is equal to 4. Clear? For 6, this is not prime number, but there is a concept. You can divide this number into 2 multiples. You can break this number into 2 multiples. 3 into 2. Okay, then you can calculate GCD. Okay, next, for with this, if you have a big number, for example, if you have 23, if you have 23, 23 is the prime number or not? It is the prime number. So this means quotient function of 23 is equal to 23 minus 1 is equal to 22 is equal to 22. So this means quotient function of 23 is 20. Quotient function of 23 is 22. But this formula is only valid for prime numbers. This is for prime numbers. In this way, you can find co-prime numbers. How many co-prime numbers you have? Okay, 23 के कितने co-prime numbers होंगे? 22 होंगे. ठीक है, ये आप कैलकुलेट कर सकते हो. सेट में हमारे जो नंबर होंगे ना, that are 22. मैंने क्या बोला था? क्वोशिएंट फंक्शन क्या होता है? The elements in the set. जितने एलिमेंट्स होंगे सेट में, these are that value. अगर 22 है तो 22 is the quotient function. Okay, students. Now another thing, with quotient function, देखो phi a into b, phi a into b, you can write this like this: phi of a multiplied by phi of b. You can write in this way: phi a into b is equal to phi of a into phi of b. Let us suppose if you have a number 5 of 35, 5 of 35. Now 35 is the prime number or not? It is not prime number. So you can divide, you can break 35 into two multiples, which are 7 into 5 is equal to 35. Okay, so you can write 5 of 7 into 5 of 5. In this way, you can write this number 35. Okay, and 5 of 7, and these should be co-prime numbers. These should be co-prime numbers. ये जो हम break करेंगे ना, इस number को break करेंगे. A and B को हमने क्या किया है? इस form में लिखा है. A and B should be co-prime numbers. A and B should be co-prime numbers. A and B क्या होने चाहिए? Co-prime numbers होने चाहिए. फिर ये हमारा formula लगेगा. Okay, now the 35 is break into two multiples, 7 and 5. Now 7 is a prime number, 5 is also a prime number. So what is the formula? If we have n is equal to prime, then we have n minus 1. So here 5 of 7 is equal to 6 and 5 of 5 is equal to 5 minus 1, 4. That is equal to 24. This is the value of quotient function. This is the value of quotient function, that is 24, 35, 24. Okay, ये क्या होगा? हमारा quotient function आ गया. Now let us suppose if you have 15, 15 is not a, if you 5 of 15, 15 is not a prime number, but with this formula you can break this number with two multiples, 3 into 5, that is equal to 5 of 3 multiplied by 5 of 5. 3 into 5 15 होता है. So this means 3, these are prime numbers, so we will use this formula. Okay, so this means 3 minus 1 is equal to 2, 5 minus 1 is equal to 4, that is 8. This is our quotient function of 15, that is 8. Means 15 or 8 elements जो है वो क्या है आपस में को प्राइम नंबर है जिनका जीसीडी 1 है। ठीक है, जिनका जीसीडी क्या है 1। अगर मैं लिखूं 1 2 3 4 सोन अप टू 14 लेस देन 15 होना चाहिए, तो इसमें से 8 एलिमेंट्स जो है वो क्या है 15 के साथ को प्राइम्स हैं जिनका जीसीडी क्या है 1 है। ओके, सो द टोटल नंबर्स are A, which have GCD 1 with 15. Okay, this is about Euler's quotient function. So, इसमें कोई डाउट है तो बताओ। This is all about Euler's quotient function. हाँ जी स्टूडेंट्स, ओके देखो सिमरन जी, suppose we have 35. We have 35. This is not prime number, but we have to find the quotient function. Means how many numbers, if we, अगर मैं 35 को मैंने इसका फॉर्मूला क्या कहता था कि टोटल नंबर्स लेस देन n, 35 से n है, मैं लिखूं 1 2 3 अप टू 34 तक लिखूंगा, फिर मैं 1 को 35 के साथ इसका जीसीडी फाइंड आउट करूंगा। ठीक है, फिर 2 का 35 से करूंगा, 3 का 35 से करूंगा, 4 का 35 से करूंगा, सो ऑन 34 का 35 से करूंगा कि कितने नंबर्स हैं 35 के साथ जिसका जीसीडी 1 आ रहा है। ओके ओके, हाउ मेनी नंबर्स इन द सेट विच हैव जीसीडी 1 विद 35? यस, आवाज आ रही सबको? ओके, तो सिमिलर जी इसमें क्या है कि 35 अगर हम जीसीडी फाइंड आउट करने बैठे ना तो हमें बहुत लेंथी प्रोसेस है, और इसके ऊपर फॉर्मूला भी नहीं लग सकता। ये वाला फॉर्मूला किसके ऊपर लगेगा? ये था quotient of n is equal to n minus 1. This formula is valid only for prime numbers, but this is not the prime number. But we have a method, we have a rule, that is phi a into b can break into phi of a and phi of b. So this 35, we can break this 35 into two multiples, 7 and 5. 7 into 5 is equal to 35. Now we take the quotient function, Euler's quotient of these two numbers, because these are two prime numbers. So here we have 35. 35 is divided into two parts, 7 and 5. No, 5 of 7 and 5 of 5. 7 and 5. तो वही चीज हमने लिखी है, इसका quotient function निकालेंगे और इसका, these are prime numbers and we can easily find the GCD, the prime of prime numbers with this formula. ठीक है, इसके साथ हम क्या है 7 minus 1, n की वैल्यू क्या है 7 minus 1, here n is 5, 5 minus 1 is equal to 4, 6 into 4 is equal to 24. This means total 24 numbers which are co-prime with 35. Which are co-primes with the 35, and this 24 is called quotient function. This 24 is called quotient function. Okay. Okay, you have 1 minute more for the poll. After that, I will end the poll. अभी तक कोई भी आपको डाउट है, कोई प्रॉब्लम है, नहीं पता चला, तो यू कैन आस्क मी. देखो हमारे पास कुछ टॉपिक्स है जैसे यूलर्स थ्योरम, फॉर्मेट्स थ्योरम. All these topics are needed for the next algorithm, that is RSA. That is RSA algorithm. For that purpose, we are doing these topics, and also these are the part of our syllabus. Okay, but these topics are required for next algorithm, that is RSA. Okay, so I'm going to stop and the poll. ओके स्टार्ट करें नेक्स्ट टॉपिक. नो डाउट. ओके ठीक है, नेक्स्ट करते हैं स्टार्ट हम. यूलर्स थ्योरम. आवर नेक्स्ट टॉपिक इज यूलर्स थ्योरम. Next topic is Euler's theorem. Euler theorems state that x and n are co-prime positive numbers. Euler's theorem state that if x and n are co-prime positive integers, then what is co-prime? Co-prime क्या होता है? What is co-prime? Yes, what is co-prime? Yes, अंजलि, अनम्यूट करो.
हेलो
हेलो.
हेलो.
हाँ जी अंजलि. हेलो.
हेलो सर, आवाज आ रही है? हेलो.
Yes. हाँ जी आ रही है, बोलो बोलो अंजलि. Yes, Arish Khan, unmute yourself. Arish.
Yes, sir.
Arish.
Good afternoon, sir.
Good afternoon. Arish, को प्राइम नंबर्स क्या होते हैं? यस दीप्ति, अनम्यूट करो.
सर गुड आफ्टरनून सर.
गुड आफ्टरनून.
सर जिनके बीच 1 सिर्फ कॉमन फैक्टर होता है.
यस. which numbers are called co-prime numbers? Those numbers which have GCD 1. जिन नंबर्स का GCD 1 होता है These numbers are called co-prime numbers. And Euler's theorem states that if x and n, two numbers, these are two numbers which are co-prime positive number, then we have x raised to power quotient of n congruence 1 mod n. This is a formula for Euler's theorem. If x and n are co-prime positive integers, then x raised to power quotient n, quotient function n, congruence, triple lines का मतलब है congruence 1 mod n. What does it mean? देखो quotient function, तो हमने quotient function जो है phi of n we have already explained, ठीक है, in the last topic. Now congruence means CONG. These three lines represents congruence. This is called congruence. This means if I write 26 congruence 1 mod 5. Okay, what does it mean? This means 26 mod 5, 26 mod 5 and 11 mod 5. This is the meaning of this. 26 congruence 11 mod 5. This means 26 mod 5 and 11 mod 5, it should be equal. अगर 26 का मॉडुलस निकालते हो तो that is equal to 1, 5 का और 11 का भी निकालते हो वो भी हमारा 1 ही आएगा, दोनों क्या आएंगे 1 ही आएंगे, ठीक है. That is the meaning of congruence. This can be write like this, ठीक है, इस चीज को हम इस तरह से लिख सकते हैं. Okay, and this is phi of n is the quotient function, Euler's quotient function. This is our Euler's quotient function. Okay, x and n are two co-prime numbers. Okay, for example, now we take the example of this. For example, x is equal to 11 and n is equal to 10. अब हमने ये चेक करना है, we have to check x and n. The definition of Euler theorem is x and n should be co-prime positive numbers. ठीक है. Now we have to find that 11 and 10 are co-prime numbers or not. Of course, it is. These two numbers are co-prime numbers. 11 and 10 are co-prime numbers. Are co-prime numbers. You can find the GCD of 11 and 10 and you will find only one common factor, that is 1. Okay, you have only one which is common between these two numbers. So this means 11 and 10 are the co-prime numbers. ये भी हमारी condition क्या कर गई, satisfy कर गई. Now here put these values in this formula. X is 11 raised to power phi of n is 10. Okay, congruence to 1 mod 10. Okay, now separately we will calculate this phi of 10. This is the quotient function. And how to calculate quotient function, I already discussed in the last topic. See, this is a prime number or not prime number. Obviously 10 is not the prime number. So here we use the formula. Here we use formula, that is 10 is equal to phi of 2 into phi of 5. Okay, here n minus 1 means 2 minus 1, 1, 5 minus 1, 4 is equal to 4. Okay, so phi of 10 is equal to 4. This means there are 4 numbers from 1 to 9 which are co-prime with number 10. Okay, what does it mean? This means we have total 4 numbers from the set 1 to 9 and only 4 numbers are co-prime numbers with 10. Okay, so quotient of 10 is equal to 4. So here you will place 4, that 11 raised to 4 congruence 1 mod 10. Okay, if you calculate the value of 11 raised to power 4, that is equal to 14641. Now calculate, after calculating this, what does this mean? Here, मैंने आपको बताया था, ये इसका मतलब क्या है? 1464 mod 10 and 1 mod 10. Now calculate the modulus, you will get the result 14641. Here is 1. There is 1. Okay, you will get 1. You will get 1. ये जब कैलकुलेट करोगे ना, इसकी वैल्यू 1 आ जाएगी, इसकी वैल्यू भी 1 आ जाएगी. मॉडुलस करोगे ना जब इसका 14641 mod 10, that will be equal to 1. That will be equal to 1. ओके, तो ये दोनों की वैल्यू क्या आ जाएगी, फिर इक्वल आ जाएगी आपकी. क्लियर? दोनों की वैल्यू इक्वल आ जाएगी, यहाँ पर 1 आ जाएगा, यहाँ पर 1 आ जाएगा. Okay, like this you can use Euler's theorem and calculate various numbers. Now suppose, for example, if you have n is equal to 4 and x, if you have a question x is equal to 4 and n is equal to 165. X is equal to 4, n is equal to 165. By using the Euler theorem, calculate the value. Hurry up. You have 2 minutes. X is equal to 4, n is equal to 165. By using the Euler theorem, you will calculate give the answer. Okay? 2 minutes है आपके पास, जल्दी करो. तो ये आंसर दो. मैसेज करो, क्या इसका मैसेज क्या आएगा? हैंड रेज कर देना, जिसका भी मैसेज आ जाएगा. यस कमलेश.
ये कॉन्ग्रुएंस वाला समझ में नहीं आया, जैसे कैसे?
ओके, देखो कॉन्ग्रुएंस मीन्स कुछ नहीं है, कुछ इसमें नहीं है. अगर मेरे पास ये देखो सिंपल सा है, मैं लिखता हूँ अगर 26 कॉन्ग्रुएंस 11 mod 5 अगर मैं लिखता हूँ, यही चीज बनी ना मेरी, ये वाली भी. तो इस चीज को मैं इस तरह से लिख सकता हूँ. दिस कैन बी रिटन लाइक दिस 26 mod 5 and 11 mod 5. बस मॉडुलस निकाल लो, 10 डिवाइडेड बाय 5 एंड 11 डिवाइडेड बाय 5 कर लो. तो आपके पास जो रिमाइंडर आएगा वो यहाँ पर लिखोगे आप, 1 रिमाइंडर आएगा. 10 divided by 5 you will get the 1 remainder, 11 divided by 5 you will get the 1 remainder. Here also 1464 is divided by 10, you will get the 1 remainder. 1 divided by 10 you will get the 1 remainder. Okay, so here this line 26 congruence 11 mod 5 can write like this. Okay, yes anybody, किसी का आंसर आ गया? Yes, any student? Raise your hand. You just don't calculate the power. Don't calculate power. यहाँ तक आप बस मुझे बता दो कि यहाँ कितनी पावर आती है और ये क्या चीज है, बस यहाँ तक कैलकुलेट करके बता दो. पावर इसकी बहुत बड़ी हो जाएगी. सो यू हैव टू कैलकुलेट यहाँ तक, बस बताओ मुझे. ठीक है, पावर मत कैलकुलेट करना. यस माधव.
सर 4 की पावर 96 कॉन्ग्रुएंस 1 mod 165.
4 की पावर
96.
नहीं, गलत आ रहा है. नो, दिस इज रॉन्ग. एनीबडी एल्स? आंचल? Yes, Anchal, unmute yourself.
Hello.
Yes.
Sir, 4 की power 80 congruence 1 mod 165.
4 की पावर 80.
Congruence 1 mod 165.
Yes. ठीक है. हाँ जी स्टूडेंट्स, इसका जो आंसर आएगा डेट इज 4 raised to power 80 congruence 4 raised to power 80 congruence 1 mod 165. This will be the your answer. ठीक है, this will be your answer. 165 को आप लिख सकते हो ना. 165 को हम कैसे लिख सकते हो आप लोग? 15 into 11 में लिख सकते हो ना. ठीक है ना. बट here 11 is the prime number but 15 is not prime number. Again you will break this number into two multiples, 3 into 5. ठीक है, in this way then you can find the value. Okay, clear है? Yes students, any doubt regarding Euler's theorem? इसके हम एग्जाम्पल करेंगे. क्लियर? नेक्स्ट टॉपिक स्टार्ट करें फिर. बिफोर स्टार्टिंग द नेक्स्ट टॉपिक यू हैव अ पोल ऑफ 3. थर्ड पोल. ये सेकंड क्वेश्चन है. 3 पावर 2 रेस 3 की पावर 201 है. 3 रेस टू पावर 201 मोड 11. ओके, 3 रेस टू पावर 201 मोड 11 ये क्वेश्चन है. चेक करो, अब आ गया होगा पोल। अभिनव अनम्यूट करना। इसी के रिलेटेड है सिमरन जी। इंटीग्रिटी ऑफ मैसेज डॉक्यूमेंट रिसीवर क्रिएट। हैश टैग होता है इसका मतलब। ओके, तो एंड करने जा रहा हूँ पोल में। यस, आई एम गोइंग टू एंड द पोल। Okay, so students, this is about Euler theorem. Next is Fermat's theorem. Next theorem is Fermat theorem. That is very easy. Next is Fermat theorem. Fermat. Next is Fermat theorem. This theorem is basically related to Euler theorem. Okay, and it is the special case of the. This is also the case of the Euler theorem. Just in this we have if n is prime and x is positive, integer in Fermat's theorem, if n is prime and x is a positive integer not divisible by n, not divisible by n, then we have a formula for it: x raised to power n minus 1 congruence 1 mod n. कहने का मतलब क्या है कि if n is a prime number and x is positive integer, n is prime number and x is positive number, x is positive number, positive integer not divisible by n, x is not divisible n. ओके, तो सिंपल सी बात है कि n एक प्राइम नंबर है, x जो है वो क्या होना चाहिए, ये भी पॉजिटिव इंटीजर है, एंड x इज नॉट डिविजिबल बाय n. ये इसकी कंडीशन है. दीज आर दी कंडीशंस. एंड आल्सो x एंड n शुड बी को-प्राइम. x एंड n शुड बी को-प्राइम. ये भी कंडीशन होनी चाहिए और ये कंडीशंस भी सेटिस्फाई करती होनी चाहिए. ओके, एंड देन वी हैव x रेज़ टू पावर n minus 1 congruence 1 mod n. Now this n minus 1, n is prime number, x is not divisible by n, ये मैंने आप लोगों को बता दिया है. Now अगर आपको याद है phi of n is equal to n minus 1 for prime numbers. For prime numbers, here n is also prime number, and this is a Euler's quotient function. In Euler quotient functions, n also prime number. If n is prime number, then we have n minus 1. Okay, so you can write this. We have x phi of n 1 mod n. This is Euler theorem. This is Euler theorem. Okay, now replace phi of n with n minus 1. X raised to power n minus 1 congruence 1 mod n. This is the Fermat's theorem. This is Fermat's theorem, or this is the case of the Euler theorem. Okay, this is Fermat theorem. Okay, students. Now, for example, if x is equal to 3, n is equal to 5, then these values, firstly we have to check these conditions. 3 and 5 both are the co-prime numbers, and next n is prime number. Okay, x is positive integer, yes, x is positive integer, n is a prime number, and next condition is, and x is not divisible by n, ये भी condition satisfy कर रही है, and then both numbers should be co-prime, and so x and n also co-prime numbers. So these conditions are satisfied, so we can calculate Fermat's theorem. So we can calculate the value for Fermat's theorem. So x raised to power, here n is 5, so 5 minus 1 is equal to, x is 3 raised to power 5 minus 1 is equal to 3 raised to power 4. Okay, congruence to 1 mod, what is n? N is 5. So calculate the power that is equal to 81 congruence 1 mod n. Simple है. If you have x is equal to 3, n is equal to 5, तो ये हमारी चेक, पहले हमने क्या चेक करना है? फर्स्टली वी चेक ऑल दीज कंडीशंस, these two numbers are satisfying. So the first condition is both the numbers should be co-prime. So these are co-prime numbers because their GCD is equal to 1. Okay. Second, n is prime number. Yes, n is prime number. X is positive integer. Yes, x is positive integer and not divisible by n. And that condition is also satisfying. Okay. So put these values in this formula where x is equal to 3, n is equal to 5 minus 1. Okay. And that is equal to 3 raised to power 4, that is equal to 81. So 81 congruence 1 mod 5. This is our result. This is our result. 81 congruence 1 mod 5. Now you can divide 81 with the 5, you will get 1, and 1 divided by 5 you will also get 1. So both the condition is true. Okay. So here this Fermat's theorem can also be right in another way, that is x raised to power n congruence x mod n. Okay, x raised to power n congruence x mod n. You can also write Fermat's theorem in this way. Okay, again you can calculate, put these values, x is equal to 3, n is equal to 5, and you can calculate the values. Okay, so it is easy, बहुत easy है Fermat's theorem, so you can easily इसको solve कर सकते हो. Okay, now you have a question by using Fermat's theorem. X is equal to, verify Fermat's theorem. So write down, students, verify Fermat's theorem. X is equal to 6 and n is equal to 7. Verify Fermat's theorem. X is equal to 6 and n is equal to 7. So solve the Fermat's theorem. जल्दी करो, 2 मिनट्स का टाइम है आपके पास, so hurry up. You have 2 minutes to solve this problem. बहुत इजी है, दोनों मेथड से करके देखना, दोनों मेथड से करके दिखाओ क्या आंसर आता है. Yes, any students, raise your hand. अगर कर लेते हो तो अपना मैसेज कर दो, raise your hand. आपने बताना है कि दोनों साइड्स क्या होनी चाहिए, ये बताना है ट्रू होती है कि नहीं ट्रू होती है, कैलकुलेट करके. Manpreet Singh, true. Yes, anybody else? Yes, Simranjit Singh Walia, unmute yourself. Simranjit Singh Walia.
Yes sir.
हाँ जी, ट्रू आती है कि फॉल्स आती है, दोनों साइड?
सर ट्रू.
ट्रू. क्या वैल्यू आती है?
एक मिनट सर.
x raised to power n minus 1 congruence 1 mod n. लेफ्ट साइड कौन कितनी वैल्यू आती है, पावर कितनी बनती है 6 की, x की पावर 6 है ना।
सर 243
2 4
3
नहीं, गलत आ रही है सिमरनजीत सिंह वालिया। ओके ठीक है, कर दो म्यूट। हेलो, यस स्टूडेंट्स, इसकी जो वैल्यू आती है ना, बहुत इजी है। इसमें डिफिकल्ट क्या था, वी हैव x इज इक्वल टू 6 एंड n इज इक्वल टू 7 एंड वी हैव फॉर्मूला x रेज टू पावर n congruence 1 mod n, put these values, x is equal to 6, n is equal to 7, 7 minus 1 is equal to 6 raised to power 6, okay, that will be equal to 4 double 6 5 6 congruence 1 mod n क्या है 7, so write 7 here, and when you divide 4 6 6 5 6 by 7 you will get 1, and 1 when you divide 1 mod 7 जब आप कैलकुलेट करोगे you will also get 1, so both these are true, दोनों क्या है ट्रू हो जाएंगी कंडीशन। okay, next I have a question for Euler theorem, 4 raised to power 99 mod 35, solve this with the Euler theorem, students solve this with Euler theorem। तब तक मैं पोल लास्ट पोल जो है वो लॉन्च कर रहा हूं। You have a question 4 raised to power 99 mod 35 used, solve this by Euler theorem। so Euler theorem के आपने सॉल्व करना है और आपने इसका मैसेज करना है, मुझे अभी करके सॉल्व करके बताना है। 2 मिनट लो पोल के लिए, बाद में आपके पास 7 to 8 मिनट्स है। सॉल्व दिस प्रॉब्लम बाय यूलर थ्योरम। हैश फंक्शन क्या होता है वैसे, व्हाट इज हैश फंक्शन? Yes, hurry up students, complete the poll. Yes, students, now the solve the problem 4 raised to power 99 mod 35. ये बताओ मुझे क्या आंसर आता है इसका. 4 raised to power 99 mod 35 is equal to यस पोल डिसेबल हो गया. अब नेक्स्ट ये प्रॉब्लम सॉल्व करो. Yes, students, solve the problem. 4 raised to power 99 mod 35. Kamlesh Kumar 29. Anybody else? किसी और ने सॉल्व किया? दिवाकर 29, आंचल मित्तल 29 और आंचल 29. यस, इट्स आंसर इज 29. बिल्कुल सही है. ठीक है, तो इसको सॉल्व कर लेना. तो दीज आर दी टॉपिक्स फॉर टुडे लेक्चर. फर्स्ट वी हैव डन असिमेट्रिक. अभी किसी ने पहले सुन लो. टुडे टॉपिक्स आर असिमेट्रिक इंक्रिप्शन की. सेकंड टॉपिक इज डिजिटल सिग्नेचर and then number system, number theory, and then Euler's quotient function, and next Euler theorem, and the last topic is Fermat's theorem. These all theorems, Euler's quotient function, Euler's theorem and Fermat's theorem, all these are required for our next algorithm, that is RSA. Important algorithm है, that is the important algorithm, and all these topics are required for RS algorithm. So that's why, and these topics are also the part of our syllabus. ठीक है. If you have any doubt regarding these topics or in previous unit, you can ask me, message me. Clear? And ठीक है students, you can leave the meeting. Bye bye, good afternoon.